Okay, welcome back. Week 8, distance learning. Thanks for tuning in. This week we're going to be working on limits, more specifically from graphs and tables. Next week we'll be doing some other strategies for those limits, okay? All right, so here's what a limit is. Here's the definition, kind of an informal definition. It's going to be the y value that a function approaches as the input value x approaches some value. Okay, so here's the notation that we need to get used to. And you read it like this. Find the limit of the function as x approaches some number c. And then whatever number we find out, that'll be the answer over here, equals some number l. Okay, we've seen some of this notation in the first semester. When you see a plus right here, sometimes there won't be one. It might just be approaches c. Okay, that's just a standard limit. But one-sided limits will have a plus or a minus right here in this notation. And this is how you read this. From the right, from the left. That's a key word. We don't want to assume it's to the right and to the left. So for example, if I peek ahead at this first example we're going to do here in a moment, it says as it approaches -4 from the left. So let's just peek at a number line here and have that discussion right now. All right, so what are some values as I approach -4 from the left? Okay, so from the left is coming in from this side, not going to the left. If I said to the left, then it'd be going to -infinity. Okay, so that's a key word we don't want to mess up. Coming in from the left on the number line would be values like -5, -4.5, -4.1. Those are values coming in from the left side. From the right side would be values like -3, -3.5, and so on. Let's get close to -4. Okay? All right, so there's your little introduction to limits. Limits basically give us a way to evaluate functions in pre-calculus and calculus when it's undefined. Okay, a little side note here. For example, if I told you to evaluate this function for x equals 5, we'd have a problem with that because when we plug in 5 right here in the denominator, we're going to have a 0. Okay, so we wouldn't have a value, be undefined. All right, so limits allow us to still come up with a value for this function as it gets close to 5, not equal to 5, but close to 5. Okay. All right, so here we go. Let's take a look at example 1. Let me pull it up here on Delta Math. Here's the first example. Here's the 3 subsets, by the way, that you're going to have. 5 questions from each. So the first title is Finding Limits Graphically One-Sided. Okay. Okay, so we're going to start off with the graphs, and then we'll finish with tables. All right, so for this function shown below, determine the limit of the function as x approaches -4 from the left. It's pretty faint, but there's a little minus sign up there like that. Okay. All right, so you want to think about some x values that are coming in from the left. I think a table is a good idea, but here let's take a look at this first. Again, I'll make sure you know how to read this. This is what you need to get from this. What is the y value as x gets very close to -4 from the left? Okay, that's how we interpret that. I think a table might be helpful just to help organize your thoughts, and you can see where these y values are tracking. All right, so as it's coming from the left, as we talked about, these are some values that we could use. You don't have to use these, they're just some examples. Pick some. So when x is -4.5, let's use the graph to estimate what y is. So look in here, -4.5. This would be about where my cursor is right here. And if I go up to the corresponding y value and go across, looks like it's around 0.5, right? So the y value is close to 0.5. Let's go on to -4.2. -4.2 would be right about here. If I go up to the corresponding y value, it's somewhere around 0.8 or 0.9, okay? All right, now as I get really close to -4, not equal to -4, notice I said not equal to -4, because if you look, there's an open circle and an open circle. There is no value at -4. This function is undefined, but that's okay. We're not looking at -4, we're looking at the value of y as it gets close to -4. All right, so -4.001 is almost right at -4, just a little to the left. If I go up, what would be the corresponding y value? really close to 1, right? Like a 0.99. All right. So now using this data, as x gets close to -4, what are the y values approaching? Well, our best guess here is 1. They're approaching the value of 1. And that's what we put in for the answer. Okay, so down here it's going to say, what's the value of the function? This is kind of the L value. That's the answer. And we're going to say it's equal to 1. Okay, and submit our answer. And we got it right. Okay. Now what's kind of cool about the solution, look what they do here. They really give you a good visual. These problems are great on Delta Math. As x gets closer and closer to -4, they're moving this cursor along. Look at the y values. They get closer and closer to 1, right? 0.999. So once again, it's a good tool, good little visual aid of what's happening. All right, so there's that answer. Done. Let's go on to example 2. Okay, now this one's going to be right-sided. I wanted to show you from both sides because you're going to have a mix of these. So for the function shown below, determine the limits of this function as x approaches 3 from the right. Okay, so what are some values that are getting closer and closer to 3 from the right, coming in from this direction? Okay, so for example, I got the number line here so we can think about this, like when x is 4. Let's see if we can figure out the y value is. And then let's go to like 3.5. Figure out what the y value is. And then maybe something closer, like a 3.1 or 3.01, right? Really close to 3. These are values coming in from the right. Let's go ahead and approximate these y values, okay, from the graph. So when x is 4, and I go up to this graph, it looks like it's just off, maybe 11 or 12. So when x is 4, y is 12. Okay, let's go on to 3.5. 3.5 is here. Go up. Our y value is somewhere around 8. All right, and then when we get closer and closer to 3, but not equal to 3, what would we assume that y value is? It looks like it's maybe just above 5. Let's just put 5.01. Okay, so when you're answering these from the left-sided and the right-sided approach, it's kind of like the ending y value. You know, as you're scrolling along, using your finger or your cursor, what's kind of the ending y value that you're looking at? And it's really close to 5. Okay, so these are tracking down towards 5, and it should be evident from the graph. So the answer to this limit is the answer right here, basically, where I have this question mark. The answer is going to be 5. Okay. All right, so that's what we put in there for our answer. Sometimes it's going to be undefined and does not exist. We're going to get to that in these next examples. But for these first two, we have answers to plug in there and submit. Okay. All right, the next 3 examples I'm going to take you through. There's not much to show you on paper. It's mainly going to be all on Delta Math. So let me just make this bigger for you. Oh, that didn't work out very well. I can't get rid of that right now. So here we go. Okay, this one has a few questions on this graph. So it says, excuse me, answer all the questions below about the function f of x when x equals 0. Okay, so first one, we see a one-sided limit, another one-sided limit from the right. Now this one's just a standard limit. If it doesn't have a negative or a plus, it's just a regular limit. So let's start with the one-sided limits and then I'll explain this one. This is new. Okay, and this is old. This is stuff you've been doing since Algebra 2 or Algebra 1. So maybe we should start here. Evaluate the function when x is 0. So let's go to the graph and figure out what that is. When x is 0, we start right here at the origin. What's the value of y? Well, there's really nothing here. This is an open circle, so we can't report that. So we're going to call this undefined. So at 0, it's going to be undefined. Okay? No, nothing new there. That's just review. Okay, now the one-sided limit. So as x gets closer and closer to 0 from the left, I'm just going to track along on my cursor here. Closer to 0 from the left, we want to look at these values, right? -2, -1, -0.5. So if I'm tracking along, what's the value of the y getting closer and closer to? Like -3.5, -3.1, -3. Okay, it's approaching that y value. So we should throw in -3 here. All right, from the right, it's actually approaching the same number. If I'm coming in from this side, I'm looking at values of 1 and 0.5 and so on. Look at the values of y. They're getting closer and closer to -3 as well. So we throw in -3 again. Okay, now here's a standard limit. If the left-sided limit and the right-sided limit approach the same number, then that will be your value of this limit. Okay? Say that again. This is new. If the left-sided and the right-sided limit approach the same number, then that will be your standard limit. If they don't approach the same number, which is going to happen probably in the next example, like for example, if this was -3 and this was 10, I'd say it doesn't exist. All right, so that's going to happen here soon. Okay, so those are all there. When you submit your answer or show the solution, they do that little cursor being moved along, which is helpful feedback. Okay, so anyways, there's the answers. Let's move on to the next one. Okay. Okay, so when x equals 6, that's our focus point on this graph. This has a little different circumstance, so I wanted to show you two of these. Okay, so here we go. Let's go with f of 6. Review problem. At an x value of 6, what is the corresponding y? Well, this is a filled in dot now, so I can use that. That corresponding y value is 0. Okay, so that's what we're throwing in there. Okay, let's go back to the one-sided limits. This is from the left, so as x approaches 6, from the left, I'm looking at values of 5, 5.5, 5.9. What's the values of y tracking towards? They're tracking towards 0. How about from the right? Well, from the right of 6, I need to analyze when x is 7, 6.5, 6.1, right? So now the y values are down here. So these values are tracking towards a y value of -4. All right, so now to the standard limit. This is not one-sided, this is a standard limit. As I mentioned on the last example, these one-sided limits have to be equal to have a limit here. They've got to be basically approaching the same number from the left and the right. They are not approaching the same number. It's very clear on the graph, right? From the left, it's approaching 0. From the right, approaching -4. So this is the scenario where you say does not exist. Okay? Throw that in there, submit our answer, and let's just go ahead and take a look at their feedback real quick. See, doesn't exist. Here, right here. Since the limit from the left does not equal the limit from the right, this is when we say does not exist. All right, let's move on to the last set of problems. This is finding limits from a table now. Now, I already set up a table for you in example 1 because I knew this was coming, and it's also a good way for you to organize your thoughts. But we're going to kind of create a table and analyze these y values to get our answer. All right, they're not going to present a graph to us now. Okay, so here we go. Let's finish with this one. Okay, so enter x values into the table below to determine function values for a function for various inputs. Use the function values in order to determine the answer to each question below. All right, so they're giving us 4 questions again. And let's just start with this first one. As x approaches -5 from the left. So they want you to come up with some values to start investigate this. It's a nice little table tool that they're providing us. So values of -5 from the left. Think about the number line again. What would we maybe use? Coming in from the left, maybe a -6, -5.5 would be some values that we want to plug in. So let's start with -6. So -6, and then you just hit try value. Okay, it creates a little tally for us here, which is nice. Try that value, and let's go really close to -5, like a -5.01. Okay, and let's try that value. Okay, so looking at this table, as I already demonstrated here before, looking at these y values, what are they approaching? Looks like 3, right? That's going to be our best guess of the ending points. So we're going to throw in 3 for this answer. All right. Now, coming in from the right, we can use this tool the same way. But if I'm coming in from the right on -5, I'm going to use -4, 4.5, maybe -4.99, something like that. Okay. You can probably get by with just 2 of these if you want to try that. Let's clear the table. And let's go -4.5. And then let's go -4.99. I'm going to call it good. Okay, so these values look like they're approaching -2. All right, if you're not quite sure, you want to do one more and add a couple more 9s to really see what's going on. These values are approaching -2. So that's what we're throwing in here. Okay, now as we learned in the last 2 examples, these have to be approaching, the one-sided limits that is, they have to approach the same number to have a limit here. They're not approaching the same number. Okay, so this one does not exist. For f of -5, we don't have a graph to look at this time, so what I would recommend you do is just put in -5. Try the value. What do they give us? They give us -2, and you just pop in -2. Okay, and then that's it. Okay, I know these are a little new, a little goofy at times. I'm always here to help. Shoot me an email. I'd be more than happy to answer any questions for you. You guys have a great week. Enjoy the weather. But don't forget your schoolwork. All right, take care. See ya.